So we have probability that X is less than 26,000. It is equal to probability that Z is less than 26,000 divided by 2550. This is just for me to type, then I'll complete it here. 26,000 minus 27,635, which is the mean. So value minus mean divided by standard deviation. Which is equal to probability that Z is less than, this is 26,000 minus 27,000 is 1,635 minus divided by 2550. Can you use your calculator to find this? Negative 0.64, which is equal to, we go to the table, negative 0.64 negative 0.264. So you can write that 0.264. Anyone using Excel, because I keep using Excel here and I'm not sure if any of you like or feel comfortable using it. If you are using Excel, you just put normal distribution. Yes. No, I would have not read it well. So this is 6,4. Okay, let's go back to the table. This is 0, 1, 2, 3. So this is 4. 2, 6, 1, 1. Okay? 2, 6, 1, 1. Okay? So when you are reading the table, you should be careful about what position you are. Sometimes the difference is not much anyway, but I will know that this is the answer for 4. So nobody's using Excel, so I don't want to waste time always doing Excel then. Yes, after getting this, you do 1 minus this. An educational study to be conducted requires a test score in the middle 46% range. If mu equal to 100 and sigma equal to 15, find the highest and the lowest acceptable test score that would enable candidate to participate in the study. Assume the variable is normally distributed. Here, this study, for example, you want to, a practical example is, you want to conduct an experiment and you want people with, let's say, a normal blood pressure. And you want your normal blood pressure to be people that are in the middle 46% of the distribution. So this is the middle. And we have these two numbers. So 46% here, we'll have here 0.23 and here 0.23. You will want to find Z and Z. So if you get this value, we will be using the formula sigma Z plus mu for these two values. If this area is 0.23, what will be this area? 0.27. So we will go to the table to find a Z value corresponding to left area of 0.27. It will be a negative number. I will use both numbers, the negative and the positive. .27 we are between these two numbers. So which of the two is closest? Look at these two numbers. Your answer is not going to be very different, whichever one you choose. So if I'm using Excel, I do equal to normal. I will use, with Excel, I will get the answer. If I like, I get the answer directly. So if that can motivate you in using Excel. If I use normal inverse, then I will put the area 0.27. Then what was the mean? The mean is 100. And the standard deviation, 15, 1.5. Then I get one of the values. Then I go, same thing, normal. I use inverse directly. Instead of 0.27, I will do 1 minus 0.27 now. That will be 0.73. Now, if I want to use the normal inverse, normal standard inverse, I'll put the probability here, 0.23. And I have negative 0.738. Let's look at the table. Oh. What did it was 0.27. 0.27. Did I use 0.27 as area when I was doing it? Okay. Yes. I use 23 now. Equals to normal standard inverse 0.27. 0.612 or 61. We only need two of them. This is 0.27. So we have first Z equal to negative 0. Let's put 62. Or Z equal to 0.62. So X will be equal to 100 times negative 0.62. 15 plus 100. And x will be 15, 0.62 plus 1. Can you use calculator to find this?
The first one is 90.85.
90.85.
And then B would be 109.19.
So we can choose a test score between 91 and 109 or 91 and 110. You can round it up. That's not really what's important. So if you were using Excel, you will get it faster, but you don't want to get confused. Use this method that you know. Continue to practice with the method that you know. So area at the middle is 0.46. So area at the tails is 0.27. And the z value, so that the area between minus z and z is 46, is z equals to 0.62. Using the formula, this is the inverse formula. X equals to sigma z plus mu give us minus 15 times 0.62 plus 100, which is equals to 90.85, and x equals to 15 times 0.62 plus 100 equals to 109.15. Exercise 3. The average yearly cost per household of owning a dog is 186.8. Suppose that we randomly select 50 households that own a dog. What is the probability that the sample mean for the 50 households is less than 177? Assume that the standard deviation is 32. So because we are looking for the probability about the sample mean, we need to find, first let's compute the standard error of estimate. And the standard error of estimate is sigma x bar. Write x bar, I need to come and get it here. Which is equal to sigma divided by, you don't need to type all this. You can do your computation and just tell me sigma x bar equals to that. square root of 50. Which is equal to 32 divided by square root of 50. Which is equal to what? Using your calculator. 4.5. So now we want to find the probability about the sample mean. Probability that sample mean is less than 177 is equal to the probability that Z is less than 177 divided by 4.5. It's just for me to do the operation. 175 minus the mean, 186.8. Equals to what? 177 minus 186.8. Negative 2.16. Or we can put here equals to probability that Z is less than, which is equal to, we read the table, negative 2.16, 0. Negative 2.16, 0.1539, negative 2.16. Is that right? No problem. 146. So let's just put 0.015. In a large university, 30% of the incoming freshmen elect to enroll in a personal finance course offered by the university. Find the probability that 800 randomly selected incoming freshmen, of 800 randomly selected incoming freshmen, at least 260 have selected to enroll in the course. So this is the normal approximation. So P equals to what? The probability of success? Yeah. P equals to? Okay, we want to find the probability that at least 260 have selected, that is X is greater than or equals to 260. You can use a binomial distribution calculator to do this, and that will be correct. But we might want to use a normal approximation. So Doing the correction for continuity, this should be what? Should we add or subtract? Greater than or equal to 259.5. To continue, we need to find the mean and the standard deviation. What is the mean? Equal to 800. The mean here is the same thing as mu. Is NP, which is 800 times 0.3, which is 240. And the standard deviation, square root of NPQ, which is equal to square root of 800 times 0.3 times 0.7, that's 240. You see where I'm getting the 240 times 0.7. So what do we get here? 12.96. So we are now going to use this to be equal to probability that Z is greater than 259.5 divided by 12.96. I'm doing this just for typing. So minus 240. Which is equal to probability that Z is greater than, what is 259.5 minus 240 divided by 12.6, 12.96? 1.5. So this is equal to 1 minus probability that Z is less than 1.5. 1 minus question 1.5.9332, 0.9332. So what do you get? Using your calculator, or do 1 minus 0.9332. Binomial distribution calculator. So if I use this calculator, I will put here probability of success is 0.3. Number of trials, 800. Number of success was what? 260. And I want probability that X is greater than or equals to 260. So I should get 0.067. About that. We will not get the exact value when we are using the normal approximation. So what do we get here? Anyone have done this computation? You see how close it is to the actual, because n was actually very large. Yes. Yeah, but use the appropriate mean and standard deviation. A study of 40 English composition professors showed that they spend on average 12.6 minutes correcting a student's term paper. What is the maximum error of estimate for the 95% confidence interval of the mean time for a composition papers when sigma equals to 2.5? The maximum error of estimate is the same as the margin of error. So it's sigma x bar. Equals to sigma divided by square root of n. You don't need to write all this on the exam, right? You just need to do your computation. I'm writing this to explain. So sigma is 2.5 divided by so here is divided by square root of 2.15 divided by, it's not 5. I know. I want to type square roots. Square root of 40. So what is this equal to? 2.5 divided by square root of 40. 0.395. So find a 95% confidence interval for the mean. So the margin of error, no, this is the margin of error. I mean, it's not the margin of error, but this is the maximum error of estimate. So we will have E equals to, here we'll have E equals to Z alpha over 2. Z alpha over 2 for 95% is 1.96 times 0.395, which is equal to, so multiply that by 0.395. So now the confidence interval will be what? Remember the mean? What was the mean? 12.6. .6 minus 0.774 less than mean, mu, less than 12.6 plus 0.774. Which is, what are the values? 12.6 minus 0. So in a study of 10 insurance sales representatives from a certain large city, the average age of the group was 48.6 years and the standard deviation was 4.1 years. Assume the variable is normally distributed. Find a 95% confidence interval of the population mean age of all insurance sales representatives in this city. Here we will also again find, even it is not asked, margin of error. Here we are using the t-distribution because, why do we use the t-distribution? Anybody, an idea? Why do we use the t-distribution? What we have to use either the z or the t. Should we use z or t here? T. So we find the critical value. Can you read the critical value? Times S over square root of n. I'm typing this just for you to know. You don't have to write yes. Because sigma is unknown. Yes. The first time we were given sigma. So here we were given sigma equals to 2.5. And now we are given the standard deviation of the sample. Very important to know. So we go to the t-distribution table. What is the degree of freedom here? Nine and 95% confidence level. So what is T alpha over 2? Pardon? No, it's not 1.96 now because sigma is not given. That's what we are learning now. So you use the table, degree of freedom of 9, 95% confidence level. What do we get? 2.262. Anybody else got something else? Anybody check that? Practice using that. So multiply by S. What is the standard deviation? 4.1. Then divide by square root of 10. Equals to what? Let me take that first. Anybody get the same thing? Okay. So the confidence interval is the mean is 48.6 minus 2.93 less than the mean. To type the mean, is better to go into this. Mu less than 48.6 plus 2.93. So what is the confidence? What are the two numbers? Yes.
Do we have to do anything with the, actually, wait, never mind. Sorry, never mind, I answered the question.
A medical researcher wishes to determine the percentage of females who take vitamins. He wishes to be 99% confident that the estimate is within 2% of the true proportion. A recent study of 180 females showed that 25% took vitamins. How large should be the sample size? Here, a previous study is giving us an estimate for the population proportion to be what? A recent study of 180 females showed that 25% took vitamins. That is an estimate of the proportion. Do we get what I mean here? When you are computing the minimum error of estimate, you want to know if P is given or not. If P is given, you use it. If P is not given, you use half for P. Do we understand what I'm saying here? So N will be N is equal to PQ times Z alpha over 2 divided by E square. I want to type alpha over 2 here. So what is Z alpha over 2 here? Equals to PQ is 0.25 times 0.75 times is 99%, 2.58 divided by E. E is 2%, that is 0.02. Be careful about this. And use your calculator. 0.25 times 0.75 equals to 0.1875. And 2.58 divided by 0.02 and square times 0.1875.
I got 3,120.19. If you get a 3,121.
Okay, equals to 3120.2, which we will make it equals to 3121. So if P is given, use it. If it's not given, use half for P, and Q will also be half. One more question. You want to practice these questions for your exam. You can work your work and just type the answers. You can work on your Rough paper, you don't have to type everything. What is taking us more time here is typing, and I know you cannot type all these things. So you may just be writing the answers. You work on your rough sheet and then type the answers. So find a 95% confidence interval for the variance and standard deviation for the time it takes an inspector to check a bus for safety if a sample of 27 buses has a standard deviation of 6.8 minutes. Assume the variable is normally distributed. So we want to use chi-square left and chi-square right. What is the degree of freedom? 26. C equals to 0.95. So here we need alpha over 2 and alpha. Sorry, and 1 minus alpha over 2. Alpha over 2 is equals to and 1 minus alpha over 2 equals to 1 minus 0.025. All of this, you don't need to be writing all because you get it. I'm typing because you may come to read and you want to understand where the numbers are coming from. So now, what is the chi-square right? That is for alpha over 2. Has anyone checked that? It is equal to 41.923. Please practice how to get this. You will use the 0.975. I'm sorry, you start with alpha over 2, which is 0.025, and then 0.975. They are just symmetric. And I will copy this to save my time. And chi-square left and the left is what? 13.8. So when you have both chi-square left and chi-square right, you can find the lower value of the minimum. This is how I prefer writing. Minimum equals to n minus 1 times s squared divided by we write chi-square right, which is equal to n minus 1 here is what? Degree of freedom is what? 26. So I will write 26 here. And s squared, s is 6.8. And we can see chi-square right. Chi-square right, 41.923. Which is equal to? Okay. Now we are going to do the same here for the maximum. here will be left. And we change this to 13.844. So what do we get? Now we can say that the confidence interval for the variance is 29 less than sigma square less than 87. And for standard deviation, we will just take the square root. Taking the square root, we have. Take the square root for both sides. So what do we get? Here. Yeah, good. Practice this. That is how your exam is going to be. A little less than all of those questions, but I want you to see all the possible questions you will get on your exam. Alex, Jordan, Madeline, Hunter, Michaela, Jason, Gabriel, Nicholas, Jonathan, Hannah, Jason, and Zoom. Okay.
Send exercise number 4 real quick. I can check my answer.
Thank you, you too.
Thank you.
See you all on Tuesday for the exam, but if you have questions, you can always send me an email, we can Zoom, I can explain to you. Well, sorry for this. I just want to end.